Hello, everyone. Wish you a Merry Christmas in advance. And again, thanking all of you guys. You have taken your valuable time and joined this session. So let's, without any further ado, let's go into the session and hope we will enjoy it. Great. So today in this session, we are going to learn about methods for explaining the black box of a machine learning model. So before going into the deep, I will just take like 2 minutes to describe about what a machine learning model is. So a machine learning model, it's a kind of a nonlinear model which helps you to establish relationship between your set of data and a different predictor variable. Okay, and in turn, it will help you to predict that variable. In an example, okay, suppose I want to know that I'm working for a bank and I want to know that who of my customers will default in a loan that they have taken, default in the payment of an EMI. So in that case, the variable, the dependent variable, right? So that becomes whether the person is defaulting on a loan, and the variable that I can use to predict this feature, this thing is there are different customer attributes, like what is the balance of the customer in the previous months, right? What is the tenure? Okay, how many different bank accounts he has. So all these things. Okay. So think about this like a Jyotish thing, okay, an astrology thing. But here we use mathematics to do that. So first we establish a relationship with the between our predictor and the data that we have, and then you try to use the relationship to predict new things. Yeah, exactly. It's just like a Jyotish thing. Jyotish also does some similar thing, but he does not have a mathematical base to it. But we have. But in order to do that, earlier when I joined the industry in 2015, we have a very limited range of models. Okay. And it is like we usually use linear regression models and all. Okay. So those models are more of a statistical models, and those models, but the advantage of those models is those are very easy to interpret. Okay. But over there, we usually have to compromise on the accuracy, okay, on the prediction. But after like 2016, 2017, the use of machine learning models becomes very high. Okay. And over there, we saw that we are definitely getting a very high lift in the prediction accuracy, but there is less interpretability in these models. So these models are the set of machine learning models. The models typically, if I say the examples can be decision trees, random forest, XGBoost, or any other families of boosting, SVM, naive Bayes, and in fact, even the neural networks. Okay. So with this, let's go to the next slide and see what we have. So, okay, so suppose this is your manager. Okay. And your manager is asking you that, can you predict a model that using which you are able to predict the churning of a customer, and you are working for a bank. Okay, for a bank, churning of a customer means that you are predicting the customer who are going to close the accounts. Okay, so that is a churning of a customer, and you are a data scientist. Okay, and here you can tell, okay, that yeah, I can definitely do that, and let me build a model for that. Okay, so finally you take your time and you build the model, and you saw that the model is predicting around 83% accuracy. Your manager, obviously, she is happy because 83% is a decent accuracy. And you mentioned that your manager is happy, and she mentioned that what are the different signals you are getting, what are the different variables that is coming inside your inside the model. And then you have gone through the data, and there is something which is called variable importance. Okay. So using the variable importance, you say, okay, age of the customer, whether the customer is active in in the bank and the number of products that the customer is having. Like a product can be for a bank, the products are usually loans, credit cards, and all. So all these are products. These are coming significant in the model. So okay, so then manager is also very happy, and she has a follow-up question on that. That do you know that whether the effect of these variables, whether these are increasing or decreasing, how these variables are affecting my models? And now, being the data scientist, you don't have answer to this phenomenon. And this is now not the problem of you only, okay? This is the problem of a lot of data scientists, and in fact, me as well. So when I built a model, okay, obviously my business team always asks me that whether you are able to create anything, right? And whether you're able to find out signals that how your predictors are changing the model, so that you can create a simulation that you can change anything in your data. Suppose age, right? If I get to know that which of the age bands are actually impacting my model and impacting the churn, okay, in that case, it is very easy for me to gauge that. Okay, so that's the thing. So someone has asked me a question, right? What is the difference between a machine learning and a regression-based, statistical regression-based models? So over here, that is the difference over here that we are coming. Okay. For a statistical regression-based models, right? These are very simple linear model. Okay. Every variable is like a very linear, always related linear to the predictor. Okay. Or the over here our churn. So definitely, and we get a very close form of an equation. Okay. And we know that, okay, if my coefficient over there, if it is positive, definitely it is attributing to churn. And if it is not negative, it is not attributing to churn. It's very simple. But machine learning models are non-linear analogs of the models. Here, the variables can be related in a form of a linear way or in a non-linear way. And what is a non-linear way? We will definitely see in the demo. Okay, in the session going ahead. Okay, so this is not been taken care of in case of a linear statistical model. Again, one more thing. For a non-linear machine learning model, there is one thing which is called interactions. Interactions mean the other variables are also contributing, not one variable at one go. Different variables at one go are contributing to it. Okay, so two variables at one go is contributing to one outcome maybe at the same time. It's called interactions. Okay, so these interactions are usually not there in case of a statistical model unless you plug it in. Okay, but for a machine learning model, it is the inherent thing. Okay, so these are the things that makes it tricky, and you can't use a pre-analysis thing like a correlation. That also will not tell you the exact thing, because correlation is also a measure of linear relationship. Okay, yeah, if something is increasing, something is the other predictor is also increasing, or if something is increasing, your predictor is decreasing. So that is a kind of a linear relationship. It's very flat, right? But here, the kind of relationships we have, it may not be that much simple. So for that, linear regression is also called a simple linear regression. And these models are not as simple as those models. Okay, so we will go through the journey this data scientist had and try to answer the questions of the manager in the coming few slides. Okay. So yeah, so and we will try to decode the black box nature of the model. I will just stop the screen share for a little bit and I will just go to my next screen. Okay. And guys, one thing, like I will obviously take up the questions, but I will just take up the questions right after I finish. So here, so this is a Python notebook that I've already created. Okay. And this will do the same thing. And we will go to the same data set and go to the same journey. Okay, over here. So we will first load, obviously, the necessary libraries. Okay. Then I will load the data set. And this I will give you the links of the libraries, the data set, everything by the end of the session. So don't worry. So this is a data set. The data set has customer IDs, the surname of the customer, the credit score. Credit score is just like a FICO score, CIBIL score. Okay, that's the score. It is given by different agencies based on your data, and it describes the credit worthiness of you. Okay, the higher the score, the higher that you are a credit worthy customer. Okay, the geography, then it's the gender, then it is the age, then tenure, balance, number of products, whether he has card or not, is an active member. Active member means he is doing sales with your products. Okay, he is currently, or he's transacting in the bank. Okay, he's taking away money. He is, so based on that. So that is an activity tag. He is putting money into your bank and all. This is the estimated salary. Okay, and this is the variable that we are going to predict. So this is like the dependent variable, which is like if it is 1, then your customer is going out. And if it is 0, then your customer is not going out. So yeah, so the data has around 10,000 columns and 13 rows. And we then do some checks. The checks are like whether it has missing values or not. So all these things. Yes, I will try to give you the notebook and all. Okay, so don't worry. Yeah. So then we will do some pre-processing. I can agree with you because there are a lot of budding data scientists over here that, sir, why are you doing so much so simple kind of a pre-processing over here? We can do a lot of things definitely, but for the sake of simplicity, we will do only a very small level of feature engineering because we are focusing more on the model building and on the model explainability part. So that is the. So we were doing one hot encoding on all the categorical variables. So your categorical variables are surname, geography, and gender. If you say these are all your categorical variables. So we are doing pre-processing on this data. Okay, and it is finally done. I can show you how this data looks like. No, I can't give you the data at this moment. Okay, but definitely I will share the notebook and the data and the link. So you guys can try it out right after the session ends. And please give me your feedback in LinkedIn that how you guys have been able to tackle this. Okay, great. So this is the data that it looks like. Okay, so here we have created all these one hot encoding variables, which are just like it is creating dummies on the categorical variables. Now I will create the model. Okay, and before creating the model, I'm creating the data into training and testing. So 70% train, 30% test. Okay, that is a thumb rule kind of a thing that I'm using. You can do as well as 80-20 split. Okay, so in the next piece, we are importing some of the packages. The packages are just like cross-validation score, accuracy score, classification report, confusion matrix, ROC curve, and finally the model. And currently we are using an XGBoost model, like the data scientist that we have seen in the slide before. So what he has done, we will go to the same route. Okay. And we are building a XGBoost model over here. So now for people who don't know XGBoost, I think that will take another data session for you, the DataHour session. So to explain the concepts of XGBoost, but think about this as an ML model. Who guys don't know about it. Okay, and this will help me to predict the churn. Okay, so that's the thing. So here I am creating the model, and this is the place where I'm fitting the model. It will take some minutes, definitely. No, see, so sklearn, while this model is fitting, okay, I can definitely tell you that. So sklearn is a specific library that we use for. Okay, there is a question as well. Okay, so that is specifically used for ML models. There is one more package which is called stats models, but all the machine learning models are there in sklearn, and it's a very standard framework. So all the models, if you know the syntax of one model, it is very easy for you to train the models for the others. So that's why we use sklearn in Python. There is a question like why gender and geography have been dropped. We have not dropped. Okay, what we have done over here is that since we have created the one hot encoded variables, right? We don't need the surname, geography, and gender. So all these are now created over here. Okay, all these are now created like here in this. Like surname is created like this. So surname, there was a actual name which is called Zuef. It is actually created here, like a one hot encoded, and we don't need the variables, right? Because for that we are converting it to under one hot encoded variables. And why we do want to do one hot encoding as well? Because XGBoost only take numeric in things. Okay, numeric inputs, not a categorical. Yes, stats model can only do, yes, definitely. Stats model can only do your OLS model. So linear regression models and all. So it's mostly like a statistical library than an ML library. Okay, so XGBoost parameters, someone is asking me. So I will just tell, not waste a lot of time, but I will tell because this need an extra session. Okay, so max depth, it means the depth of the tree. Depth means if you see a decision trees, okay, so decision tree, it is just like it has a root node and there are two leaf nodes. That becomes depth of 1. And as you are growing below one below the other, the depth of the tree increases. N estimators is the number of trees that you want to train. Learning rate, it is the gradient boosting parameter. Okay, and for this you need to learn about gradient boosting models. Gamma, it is a pruning parameter. So it will help you to prune your tree and fit overfitting. Okay, subsample, it means that it is a bagging fraction that at each step, how much percentage of the data you want to fit it into your model. So if it is 1, so at each step, the full data will go into it. If it is like 0.5, then it will be a 50% random sampling that will go into your model. So higher it is, like the lower it is, it will try to predict the data well, right? So higher it is, it will try to predict the data, but it may have overfitting issues. Column sample by tree, it is same as subsample, but it is just like on the column wise. That column wise, how much sampling you want to do. Okay. Minimum child weight, it is just like that at each node, how many minimum observations you want in a data set from the data. So these are the parameters. Okay. So if it is very less, then the data model can try to learn a lot of things, lot of relationship, but it may try to overfit as well. So that is the thing. Binary logistic, this is we are using because it's a logistic regression. It's a classification model for that. Eval metric, error and AUC, this is just like for the inherent training. Makes sense? We have trained the model, and based on this, we will use a threshold based on ROC curves. I know someone has mentioned me that to explain about ROC curve, but the ROC curve, I will try to do it, but yeah. So like let me try to finish the session first, okay? But after that, if we have time, we will definitely take up the question in that case. Okay, ROC curve, because these obviously need one more data hour, like 1 hour is not enough. So ROC curve, in a one line, it will help you to get the threshold of the threshold, like because usually you get probabilities from a model, okay? And we need to get the threshold above which we can select that if above the threshold, we will classify it as 1, and below the threshold, we will classify it as 0, right? So in that case, it will help me to get the optimal threshold, okay, so that my error for the whole model is reduced. So that I can say, okay, as an ROC curve. So here, the threshold is at like 0.238216. And definitely, guys who want to get the notebook, I will definitely share it at the end of the session. Okay. So based on the threshold of 0.238216, we will create the classification report. So this classification report has a lot of things. So this is on a trained data, and the final, this is on a test data. Okay. So this is the accuracy of 83%. That analyst has also got it. We have also got it. Okay. And over here, like there are different other matrices. Okay. And so currently, for the sake of simplicity, Let's focus on 83%. Okay, on this. So this is the accuracy that we have got. Okay, there are different metrics like F score and all. And definitely I want to take one more DataHour session to explain these things only. Okay. And it is very stable. Okay. So like training data, it is 83%. If we see in the testing data as well, it is also 83%. Okay. So that's. Now we will see the next question that the analyst has faced. What are the different important features that you have got, right? So yes, we have also got the same age. It is the highest contributing. So this feature importance is helping me to get it in terms of percentages, that what is the contribution of the feature in this model. So it's a 27% contribution it is getting from age. Active member, it is getting around 24% contribution this feature is giving. Okay, number of products like 16% it is contributing. Okay, so these are the higher ones. Apart from that, we have whether the gender is male. Okay, so this is also contributing. Whether the balance, it is also contributing. Till now, we have got to the point that the analyst, that the data scientist also had so far. Okay, now we will go to the most important part and the agenda for today's topic, which is like the explainability. Now the question may come, right? What is this age? How this age is actually impacting your model? Okay, so that is how we will get it. So yeah, Trapti, so thanks for asking the question. It is based on a metric which is called Gini. Okay, it will always try to see that how much reduction in Gini it is causing. And based on that, the feature, so it fits different trees. So at each iteration, it is trying to find out that how much Gini that variable is trying to reduce. Okay, whenever the variable is coming or not. And it is creating an ensemble on top of it, like it just averages out that contribution and it finally gives you the final metric. So there is something which is called a reduction in gain, reduction in Gini and all. Okay, so here we are using the gain feature and which helps us to get that. Got it? Okay, so these are different because we have sought the feature importance metric over here, right? So if you see actually the order when you get the feature importances, the order is always like the variable that it is going inside the model, but it is not ordered in terms of feature importances. So we are here ordering it. Yes, it is a predictive power. It is, think about it as like which of the variable is contributing to your model and how much contribution it is having. And the higher it is contributing, the higher is its predictive power. Makes sense? The model is dependent on that variable. That's the thing. And the feature importances here, it is just like the gain. That is the feature importances that we have. And we are finally calculating it in terms of percentages. Makes sense? PDP. Next, the most important concept that we are going to learn today is PDP. Okay. Forecasting, we can use it, but we have to create this model in a different form. Okay, if you have to create our data in a different form, then you can use in a forecasting as well, this model. Makes sense? Okay. Now I will focus on the first part, right? That is like the partial dependency plot. So this will help us to understand the machine learning model. And so this model is actually created by Friedman. Okay. And it helps to create a plot. So these are visual representations, okay? So this visual representation will help me to see that whether this age is positively related in the model or negatively related in the model. Makes sense? Now, there are a lot of calculations that is done. There are a lot of jargons that is used, but I will try to use it. Yes, it is always help you to not the explainability, it will help feature importance, help you to know which of the variables are important for your model, which your model is dependent on what variables. So that is a thing that is usually given by feature importance. Now, how the importance is changing, the variability and how, so that will help you by these plots. So these plots will tell you those things. Make sense? Okay. So there are a lot of jargons over here, and as a new budding data scientist and new learning data scientist, we will ignore this and we will see how it is actually calculated. Suppose we have a data. So think about this one. X1, it has 3 values. This is one variable. The X2, this is another variable. Then it is X3. This is another variable. And this is my outcome variable. Y, 1 or 0. Okay, that is just like the churn tag. And it has 3 observations in the data set. For the sake of simplicity, we are only taking 3 observations. Now, what we will do over here is, see, like, we will, from this data, we will cross-transform the data to the like a second one. And here we are interested to find out how X1, this variable, is related to your in the model. How this one is coming, how this the variable is influencing the model, right? So over here, what we will do is we will cross-transform the data into this form. Makes sense? So here, what we will do is, what we have done over here is like, so for this 50, okay? We have taken this 50 constant and changed the and changed this the value of the variables of X2 and X3. So you can see 50 is over here, it is constant, and then we are taking the values of the other variables and your Y. Okay, then we have taken 20. Okay, the another value, and again the same for all the possible combinations of the other variables. Then we have taken 60. Okay, and then we have taken the values of the other variables. So we have cross-transformed the data like this. Makes sense? Okay, over here. This is a cross-transformation that we have done. Then we use our model that we have built, okay, and we used it and we got the predictions. So the predictions can be in terms of log of odds. If you just read about logistic regression, it will be very easy for you to know about it, like what are the log of odds, or you can also get it in terms of probabilities as well. It depends on different platform to platform, package to package. Okay, so over there. So think about it like it's like a cross transformation on your probabilities kind of a thing. Okay, so which values, right? So here you will see the values are changing. Okay, now what we will do for this 50, okay, we will take the average of the other variables. Okay, so this, so whatever is marked in red, like over there, we will take the average. Okay, sorry, I think there might be some mistake over here, but here it's like it's 20, so we take the average. For 50, we will take the average. For 60, we will take the average. Makes sense? Whenever we take the average, actually what we are doing, you know, in this cross transformation and this taking of the average, we are actually eliminating the impact of the other variables. And over here, we are only focusing on this 50, 20, and 60. Because see, here, this 50, 20, and 60 is there. Okay. And here it is changing, right? So here it is only 50. And whenever we are getting the predictions in terms of these 3 lines, right? Here, what we are actually doing, like we are generating all possible outcomes of the model, keeping my first variable at the first value. Okay, so here we are trying to find out the change in terms of the other variables like X2 and X3. If X2 and X3 are changing, how my model will impact. Keeping my X1 variable fixed at 50. Okay, and when we are taking the average over here, like for 50, if we take the average, for 20, if we take the average, for 60, if we take the average, right? In that case, what we are actually doing is that we are excluding the impact of X2 and X3 from here. Okay. So that is what we are trying to do. Okay. So it is always a good way. Okay. Suppose think about it. Like that, there are 2 factors. Okay. Maybe there are 2 factors. One is maybe a height the other is weight. Okay. And you are measuring some other thing. Okay. So now height and weight both are contributing. How will you gauge the contribution of only height? That okay, you will keep the height fixed first. Okay. And vary weight. So you, in that case, you will see how much variation of this way, this weight is actually creating. Okay. Now, if you just remove this variation from the data, you will get the impact of height. Got it? So this is how, this is the philosophy that is happening. Okay. Suppose there are two kids who are playing. Okay. And the two kids are fighting. Okay. And you have to find out that how much impact the first kid is actually is doing, how many punches he is doing and all. Okay. So what you will do? You will keep that kid patient, and you will just remove that kid and see how the other kid is performing. Okay. And if you can remove that impact, you will get the impact from the total impact that of the fight. How many total punches? So suppose the first kid is having 20 punches in a minute, and the second kid is having maybe 10 punches. So suppose you just remove the first kid, and the second kid is now still making punches, and he's having around 10 punches. So from the overall of 30 or 40 punches, if you just remove them, you will get the remaining punch of the other kid, which is like 10 or 20. So that is how it works. So you are just, in order to measure the impact of one variable, you just keep it constant. See how much the other players are, how much they are performing, how much the other variables are performing. Then you average it out, and then you change it and see that how much it is impacting. Okay. So here, whenever I'm taking this averaging, I am actually removing the impact of X2 and X3. Okay. So yeah. Yes, interaction is also removed, and I will come to that. There's a very good point. Okay. And I will actually remove the interaction. And here I will just find out the average, and I will plot it. So 20, 50, and 60. So this is only the impact of the X1 variable. Okay. The impact of X1 variable, no other interactions are there. And it is only like the contribution of this X1 variable over here. Make sense? This is how it is done. Sure. I will share. Don't worry. Next. So this is just like the implementation. Okay. This is the implementation of the PDP. Okay. It takes some time. It's a time-taking process. It takes 1 minute, 2 minutes for us. This smaller data set. If it's a very big data set, it takes around 1 hour, 2 hours for only one variable. Here we are trying to get it for at least 3 variables. Okay. So that's the thing. Let's see that how the plots are actually generating. Yes, see, the plots are generated, right? Now you will see, okay, see, this is the first plot, which is age. Okay, how we can interpret it. I will give you the data set as well. Don't worry, guys. So here, the age, okay, you will see like till 50, if the age increases, your probability also increases. And this is the probability for the churn. Okay. So if your age is increasing, your probability is also increasing. Okay. So this means that your chances of the person churning also increases till age 50. But after age 50, okay, your chances of the people doing the churn, it is decreasing. Got it? This is something which is called a non-linear relationship. A linear regression model will never be able to give you this insight. It will never be able to give you this insight because like over there, it will see, okay, if age increases, then your churn also increases. That kind of thing. But that is not there. This is a very important thing that is you are missing. This non-linear relationship. Now I am a business. If I run my business, I will definitely take care the people who are less than 50 people. Okay. And I can give them some offers so that they don't churn. Okay. So this is the power. Okay. Over here. Yes. So no. So Andy, what we are trying to do over here is we are trying to find out the prediction. Okay, that is fine. And that definitely you are getting. But after you get the prediction, that is definitely the prediction forecast is very important. But whenever you generate a prediction, right, your business always asks that, can I do something to change my prediction? Right? So for that, you need model explainability as well. Right? So you can create a simulation and you can change the model. And so that is a learning from the model. Post model, you are learning it. Okay. And these plots actually are helping to do that. Okay. Here now we are saying that, okay, the age is impacting it in this way. Definitely you are getting predictions. And I know you guys are very good in terms of getting predictions. But here, the thing that we are focusing is on the interpretability of the model. So this is an insight, right? The second insight that we are getting, that is an active member, right? So if your member is an active, see, the churn is actually chances is less. The probability is around 30% who are non-active. And if it is around the people who are active, it is 20%, right? So this is also a very important insight that we are getting. Okay, that is obviously it should be an active member. Then if you see the number of products, okay, the people who are having less number of products, like 2 products, they are not churning out. And the people who are actually having more than 2 products, they are churning out. So that is also a very big learning for us, right? So you can definitely go there and see the people who are having more than 4 products, and you can have a customer experience team already with them and see that what problems they are having on the products, and you can change them. So I know my future. I know the reason why my future is changing. So I can change my future as well, right? So that is what we are doing. So in this way, got it? So this is the impact. Yes. So in the feature importance, I know I answer the first question. Okay, what? Okay, I answer the question what? What are the features that is important? I answer the question from feature importance, that piece. But with PDP, I am finding out why it is important, why it is actually predicting the churn, what is happening in the data. That is, so what and why, these has to be very different. So that is what we are doing. Yes. Then I will come to the next part, which is called advantages. So first of all, see, I have interpreted it very easily, right? All these 3 plots. So it's very easy to implement and very easy to understand. The next one is, if the features are uncorrelated, then it gives a very robust measure. Someone has mentioned, right, that we are removing the interactions from the model, right? So that is it. Yes, we are, if the data has less interaction variables and less correlated variables, then we remove the interactions from the model. And in that case, PDP works very well if the data does not have a lot of interactions. The third one is, it represents the causal interpretation very well. Right? This is the causal representation. Okay. So this is something which is very well. You can get it very well. Right? I have also gone through it. What are the different disadvantages? It's only a 2-dimensional representation. It can only have your odds and only 1 variable at one go. But machine learning models are not dependent on 1 variable. It is dependent on more than 1 variables. Make sense? So over here, that is one of the flaw. Second, interactions, bigger level interactions. If you have a lot of correlated features, you will not get this plot will not at all work over there if there are a lot of correlated features. Okay. And the third one is like, see, over here, there is a variation we can see, right? For each of the values, there is a variation. And using this, we are not taking care of the variation in any way. Okay, that if I change my variables, right, we are taking an average over here, right? So these variations like minus 4.326 to minus 0.225, with the same value of 50, we can have this much of variations from the data, right? By changing the other variables, we are not taking care of this variation. So these 3 are the main side effects of this model. Makes sense? in order to tackle the last one, okay, this last one, this variation thing, there is a tweak on top of PDP, which is called individual conditional expectation plot. Okay, individual conditional expectation plot. Okay, which will help to do that thing. Over there, what we do, it is same as the calculation is mostly same as PDP. So first we restack the data into this form. Okay, like in order to remove the impact of the other variables. And then we calculate the predictions. Then what we do, for all possible values of the other variables, okay, we create different columns like this. 0.15. Okay, so I think there is some mistake in this plot. So ideally, this one should be over here. So like for 20, 0.15. So if we can follow this 60, I think this one is the correct, the correct one. 0.356, I have created here. 0.3875, I have created as a second column, second observation. I have created the third predicted value as my third observation. And finally, what I do is I create the plot on top of it. So instead, where in case of PDP, you are only getting one line, here you can get 3 lines. So I can see that, okay, for 20, my variation is this much. And this variation is the variation that the other variables are contributing. Makes sense? So this variable, this is just like -5 to 0. This is the total variation that I am getting. Got it? So this problem is now solved. The problem that we have discussed as a disadvantage, that problem is solved. Okay. So now if you see over here, if I run this practical, so there is nothing much. It's the same code like the partial dependency display. Here only the calculation changes kind equal to individual. Individual means it is just like give you all possible variations in terms of the variables in your PDP. Okay. So that is what it is giving. Let's see. Let's wait for 2 minutes for the plot to come up. Okay, someone has already given a question. Why do we need partial dependency plot? For an ML model, you will not get weights. Yes. Okay.
Subhodeep, actually, I just want to tell you this. Just give me 1 minute.
Sure.
I'll take feedback from there. After that, you will start your Q&A section, please.
Sure. So yeah, so if you see the PDP, it looks like the same, but it is much complicated, much convoluted. Okay, that is the thing. Yes, PDP is possible in R as well. So yeah, so over here, if you see the IC plot, it is similar to PDP, but it is more convoluted because you have all possible level of variation. So see how the variation changes, right, over here with the other values. So this variation you can get. Now I will go to Shapely, okay? And before I go to Shapely, I want you guys to focus on one picture, which is this one. Okay, I guess every one of us can resonate with this because this is a very recent happening. How this has happened, right? Argentina has won more than 30 years, I guess, after a FIFA World Cup. Do you think it is only happening due to this person, that is Lionel Messi? No, it is not happened due to him. This has happened. Football is a team effort where all of the other players, the 11 players, are contributing to the win. Okay, in the penalty, right? If only Lionel Messi has hit the goal, and if the others have not been hit the goal, or the goalkeeper have not been able to save the goals for France, will the team win? No. The question is no, right? Over there, like everyone has scored the goals and then the team won. The same thing happens for a machine learning model. Think about the trophy as the accuracy of the machine learning model, as the performance. Okay, the players are your features. Okay, and the game, it is the model. So all the just like a real life game, all the players are helping each other to come up with the win. The same thing, all the features are contributing to come up with the win. The same thing, this philosophy is the philosophy of the Shapley values. Okay, so that is most important. Okay, how it is calculated, I will just take you very fast because I don't have a lot of time. So what there, so it is based on coalition game theory. Okay, so first take out a random sample from the data. This is what is done inside the algorithm. Okay, just take out a random sample. A sample means one observation. Randomly you pick it up. Okay, take the variable of interest, maybe x1. Okay, the variable interest. Now over there, suppose we have 50, right? Just replace that 50 with a random value and see how much change in the prediction you are having. Random value can be 10. So suppose with 50, the value that I am getting is around 100. The prediction is maybe 100. Okay, with 10, the prediction is 20. So how much contribution is this player doing? It is 80. This value of x, which is 50, it is actually contributing 80% in your 80% in your prediction. So this is now one variable at one go. Okay, now include other variables with this. Repeat the experiment, and the values that you will get are called Shapley values. Finally, take a mean of it. Okay, this will help. This is called a marginal Shapley value, and this mean will be a representative Shapley value for the variable. Okay, so it will give you whatever condition. So now you are actually playing with the interactions. You are taking into care the interaction of the other variables. Makes sense? And this is now giving you a much robust method. And these Shapley values, you can create different forms out of it. And I will show you some of the forms. Okay, and this can be done. And see what are the different models that it is done. It's a linear model can be done by linear explainer. Tree models can be done by tree explainer. Agnostic model like SVM, it can be done by these explainers. And deep learning, it can be also done. So all these models are under the purview of Shapley. So for this, we have to import a specific library called SHAP, and we have to create this method, which is called a tree explainer, because XGBoost is a tree-based model. So we create, these are my Shapley values, though these are not very intuitive to learn, but here, the variables that, the plots that we can generate is this one. See, here, age. Over here, how it is given, it is just like that. Higher values will have red and lower values will have blue. Okay, and higher the shift in left, it means that it is predicting the churn. Okay, the value is predicting the churn value over here. Makes sense? And the lower value over here means if the curve is actually shifted towards left, then that value, that part of the value is actually contributing towards predicting non-churn. Okay, means here we see the lower age people, right? They are not predicting towards non-churn, and here this band is actually happening towards churn. Number of products. Okay, if the person does not have product, right, so then he is moving here. So here it is non-churn and here it is churn, and the number of products who is there, like, so they are churning. So in this way, this is interpretable. I will give you one more plot. Okay, and here you will see how the interactions are also playing inside the ML model. For age, this is just like a PDP plot, but the basic difference over here is, see, age is not only the covariate that is explaining the full outcome. It is correlating with each active member. So these two variables are correlated to itself. And these two variables are actually help you in the prediction. Makes sense? And similar kind of pattern we are actually getting. That's the pattern that we have seen for PDP, right? So exactly similar kind of. So it is like till 50 age, people with 50 age, it is like higher chance of churning, right? And it is with lower than 50 age, right? After 50, the people are not churning. And this band, right? If people is active, right? So then it is more contributing. And if it is not an active, it is less contributing. So there you are taking care into both the variables. Okay. And this can be done with others. So think about like number of products. It is also correlating with balance. So these two are combined. These two are impacting, not one variable is impacting. This is the counterintuitive to PDP. Okay. So now what are the advantages? Definitely it has a solid advantage in terms of PDP. Here for an ML model where you are interactions, it is definitely able to take out the interactions over there very well. It is faster implementation for tree-based models. Okay. And then it has a lot of plots inside it, right? So you can visualize it with different kind of data. The disadvantage is it is very difficult to interpret, right? Because it is like so many plots are there and all. Sometimes SHAP contributions are slower than PDP computation. Okay, because these computations are bit tricky, and the interactions can be misleading sometimes because a lot of different mathematical game theoretic intuitions goes into it, but it happens sometimes only. So you always have to think about whenever implementing that whether it is correlating with business or not. Okay, then you should take the final outcome. With this, I will stop my presentation and I will now take up the questions. Okay, so I guess there are a lot of questions. Okay, PDP with interaction features, it is not possible because it is averaging out the other variables. Okay, so that is the answer. Okay, because it is averaging out the values of the other variables. You are just taking the average, right? So it is just removing the impact of the other variables. For that, for SHAP, you are not doing any averaging. So for that, there is a claim that ML models are still black boxes, and that why can you go explaining the relationship between dependent neural? How is this? If no, what are the parameters in ML models? So this is the now ML models are not black box, and the entire intuition of this session is that ML models are not black box models. With these features, you can definitely be able to establish the relationship. So ML models are not black box models, first of all. Okay, so that is the question answer. XGBoost, I have got this a lot of times. I can definitely take a data hour session on XGBoost, and I think it's like 2 sessions are needed, one for practical, one for theoretical, but we need different sessions. It is not possible. And I have a lot of tricks to how to train an XGBoost model as well. Okay, and if you guys want something, you can contact me in LinkedIn. Okay. For a practical session, I can get a summary of the methods for explaining the black box? Okay. From the summary, it means that what I can say, like this helps you to understand the black box models. So suppose you have built a model and your business may ask you that if they can change something based on the learning of the model, you can use these plots, show it to the business, and then they can take the actions. And definitely in future, you will be able to improve your impact. So that is what. Okay. How to remove interaction? Interaction for PDP, it is removed when we take averages, right? It is actually removing the interaction effects. But for SHAP, we have the interaction. Okay. So that is the thing. Multi-correlation, I think, is the same question. Okay. It is okay. One thing is multi-correlation. Obviously, VIF is a measure. Okay. And regularization is a parameter which is there in XGBoost. So you can use those. So it will help you to remove multicollinearity. There is something which is called PCA, Principal Component Analysis. That can also help you. In R, there is definitely an algorithm. It is there. You guys can ping me in LinkedIn. I can help you over there. The R package and all. Yes. And I also have answered this question that why do we need a partial dependency plot? We don't need it for linear regression. For ML models, right? You will never know the pattern like that we got for age. I guess that now questions, right? Because it's a very nonlinear pattern. And now we are getting it through PDP and SHAP values. Okay. And using weights, you will never get it. And for ML models, you will not get any weights. It's a tree-based learner. It is not, you will not get any weights. Now in the chat section, guys, any other questions? I guess I have answered most of it. Okay, now the question of the day. What are, so can I share this, right? So please give me 1 minute. I'm sharing it with you guys. Okay, just I will stop the screen share and I will share the entire link for this thing. I know I have to go a bit fast, but that is the limitation of the data. I can't help it, but I hope that you guys have got something at least, because this I can take, like if you have 2 hours, 3 hours, then also it is not sometimes enough. I'm just sending it to everyone, the link of the notebook and the data sets and that's PPT. Cool. Thank you, everyone. Bye.